So today we're going to talk about applications of the Pythagorean Theorem. So we're going to work a couple of word problems together. I like to show a picture and do the work so that I can kind of visualize what's happening in the word problem. So we're going to read the problem. It says the foot of a ladder is placed 6 feet from the wall. So if I think about a building here and the ground, it says that the foot of the ladder is placed 6 feet. And if the top of the ladder, so my ladder is going to be at an angle like this, if the top of the ladder is placed 8 feet upon the wall, this would be 8 feet. So again, I didn't make my 6 and my 8 kind of proportional, but you're still seeing the right angle. And so what I'm interested in is how long is the ladder. So those are a picture. And once I have the picture made, then it's an easy substitution. It is 8 squared plus 6 squared equals c squared. So 64 plus 36 equals 100. And so the square root of 100 would be 10 feet tall. So that is how long my ladder is 10 feet. So again, draw your picture. If you don't understand the picture, then the math isn't going to be right. So please draw a picture. So we're going to try another one. Get a hold of it. So here's our next one. It says Johnny leaves school to go home. He walks 6 blocks north and then 8 blocks west. How far is Johnny from school if he could go there directly? So they're assuming that you understand social studies enough to know that it spells we across the center. I know there's a lot of different social studies tricks out there, but you're going to look at this. So I went 6 blocks north. I'm a little crooked, so pretend I'm a little straighter. And then he went 8 blocks west, so that would be this way. 8 blocks west. And we want to know if this was the school and this was home, or vice versa. How long is this side out here? So I'm going to move my 6 so it goes on that side. So again, it's the same math problem that we had before. We are missing the longest side. We're missing the diagonal. So when we're missing the diagonal, it's still going to be that same thing we had before. And we're going to have 8 squared plus 6 squared equals c squared. And we just worked that one out a minute ago. And we know that those are the same numbers that we had before. And so it is 8, essentially 8 and 6, instead of going 14 the long way. If he was able to cut through, it would only be equivalent of 10 blocks. All right, so we're going to do one more that we're going to talk about. It says, the telephone pole is 50 feet tall. The wire attached to the top is 72 feet. If the wire is attached to the ground, how far from the pole do we need to dig the hole to attach the wire? Okay, so let's just think about this. I have this giant telephone pole, and it is 50 feet tall. I have some wire attached to it. And we know this wire is 72 feet. This is my wire. And we want to know, where should I dig this hole right here? So here's my right angle. This time I know the longest side, and so I'm going to do 50 squared plus a squared equals 72 squared. And then we're going to solve it. So again, we have 2,500 plus a squared equals 72 squared is 5,184. We'll subtract. We'll take the square root. And a is going to be roughly, if you notice that, looks like it would round to 51.8. And in most cases, rounding it to the tenths place is enough. So this would be 51.8 feet. So I have a label. The only other type of problem that is fairly normal is when I use the word diagonal. And so if I were to do one last problem before we go, if I tell you that I have a flat screen TV, and the diagonal is what they measure it. They'll say something like it's a 48-inch. by the 48-inch, and that's the diagonal. It automatically then makes the right triangle. And then they're going to give you some numbers. So usually what happens is I would tell you that my cabinet's only 30 inches tall. How wide would it have to be? And so you'd be finding a missing leg. So don't be confused. The word diagonal is still another code word for hypotenuse. All right, so that's the kinds of problems that you're going to see when we're working story problems using the Pythagorean theorem. So great job today. Thanks.